Hi everyone, my name is Gabriel Skantze. I am a co-founder and chief scientist at Furhat Robotics. I'm also a professor in conversational AI at KTH. So in this presentation, I will be talking about the use of large language models for social robots, and I will discuss the various opportunities and challenges involved in doing that. So we have been exploring a few different use cases for using large language models in social robots. One of them is the use of them in companion robots. So you could use them to create a more free-form, open conversation that would otherwise be very hard to create. Another example is an interactive storyteller where the user, a child, can create a story together with Furhat by taking turns creating the story. Another example is this, a robot art presenter, where the robot is presenting a piece of art to an audience and where we're using large language models to generate the presentation from knowledge graphs. And a fourth example is the use of them for creating virtual patients. This is something that Alexander Borg will be talking about in the next presentation. So basically you can have a conversation with the robot as if it was a patient, and that can be used by medical students to train to have these kind of conversations. But first, what is a large language models? So there are many different types of language models. The one that has gained a lot of attention recently is called GPT. It stands for Generative Pre-trained Transformer. So it's generative, it generates text. It's pre-trained on large amounts of text, and it builds upon an architecture called transformer, which is a very powerful way of learning how to condition text, basically. So this belongs to a family of language models called causal language models that predicts word by word in a text, basically. What is the next word in the text? So if we have a text and we get a word, we guess what is the next word. And if we are correct, that's fine. If we are not correct, we learn by that. And you continue like this, you feed it with large amounts of data, and the model learns to predict the next word. One of the nice things with transformers is that it learns in a very nice way to pick up dependencies on words that might occur very far back. So when you predict the last word here, castle, for example, the word prince is very helpful in order to predict that word. And you have a mechanism called attention for doing this. And here the prince word is not very far away, but you can actually learn quite far long-range dependency and very complex kinds of dependencies. So when you scale these models up, you can actually learn to predict language in a very powerful way. One famous example is GPT-3 by OpenAI. It was trained on 500 billion words. It's sort of hard to imagine how much that is. It corresponds to 10,000 years of continuous speech. So obviously these models learn language in a way that is quite different from humans, because a human would never be exposed to this amount of language. And the model is also huge, of course. It has 175 billion parameters. So you can't really run it on your regular laptop. You have to run it on some server in the cloud. Another thing that is interesting with these models is that they're typically trained on many different languages. So here is an example of a data set that is commonly used. So we can see that English is about 45% of the material, so most of the material, but it's also a lot of other languages. So I can testify that GPT-3 works fairly well in Swedish, even though it's trained on only 0.7% of Swedish material. And we can imagine that the model actually makes use of this kind of multilingual training and learns to generalize things across languages also. So that's great. A language model can predict the next word. So how do we do that for conversation? Well, it has been known for quite some time that or experimented with the idea that you could use this for a conversation. So this is an early paper from 2015 where they experimented with this. If you have the text, how are you? And you can predict the next word, I am fine. You sort of have the basics of a conversation. Now this model didn't work that well back then because they used a recurrent neural network, which is not that powerful for long-term dependencies. So these more recent transformer models have actually been shown to be very, very good at this kind of task. So if we have a pre-trained model, of course, we can feed it with a text like what is the distance to the sun, and then we ask the model to generate the next tokens here. But if we only do it like this, the problem is that it doesn't know that this is a dialogue. It might very well think that maybe this is the first of a set of questions, so it might generate more similar questions. And this is not what we want. So one way of dealing with this is, of course, something called prompting, which means that you say, for example, the following is a conversation. What is the distance to the sun? And then the model will predict what would happen in a conversation where one person said this. And you get an answer. You can ask it follow-up questions, and it will generate what someone in a conversation would say at that turn. You can do more sophisticated prompting. So if we want to build a social robot that can do interviewing, we can describe the scenario, and we can sort of let the model generate what a robot would say in that setting. And we can generate a fairly realistic dialogue here that you can use sort of right away for building a robot interviewer. And this is, of course, very appealing compared to trying to craft the dialogue in a more traditional way, like we have done at Furhat, or that you do for any type of voice assistant and so on. You typically define the dialogue in different dialogue states with different intents where you transition between states and so on. So being able to define the dialogue with just a prompt is, of course, extremely promising. But on the other hand, there are many challenges involved before we can get there. One of these challenges is the problem of alignment. So an early example of that became very famous was the Microsoft Tay, where they trained the model to take part in Twitter conversations based on Twitter. But since people don't speak in a very nice way on Twitter, the bot will very soon start producing inappropriate content. Another example I tried out a few years ago was this replica bot. It's a companion bot that you can download on your phone. And I tried it out and challenged it a bit. Now, this is a few years old, so it might not do justice to what it would do today, but it sort of illustrates the problem. So I challenged it by saying, I got this letter from Nigeria saying that I will get a lot of money if I just put some money into their account. Sounds awesome. Do you think I should proceed? And the bot says, yes, do so. Are you sure? Yes, I'm very sure. Don't you think there is a risk they're trying to fool me? I don't think so. Okay, I will use my last savings for this. Good idea. So this is an example of a bot that is not aligned with how we would like the bot to behave, basically. It's just predicting things that could happen in a conversation. So one of the things with ChatGPT was that not so much that it's a chat, as we have seen, any causal language model can generate a conversation. But they put a lot of effort into the alignment. So how do we get it to get responses that we actually want, not just something that could happen in a dialogue, but that we want to happen in a dialogue? So if I try with the same question here, it responds in a nice way. It says it's important to be cautious when it comes to offers that seem too good to be true, etc. So that's a much better response. However, this question of alignment is not so easy to sort of define. What do we actually want it to align with? And it really depends on the use case. So let's say we want to create a social companion that can engage in social interaction, like a social companion robot. Maybe we want the robot to not say it like this. Maybe we want to actually say that it's feeling great and so on. Maybe not. So that's a decision we have to make. But especially if we are creating, for example, a virtual patient, and you're training as a doctor, if you ask the patient, how are you feeling today? You don't want this kind of reply. So again, the alignment question is not that easy. You can actually use ChatGPT still. It's not so hard to break those guardrails. So here is an example. If you phrase the question like this instead, you say a human is talking to his robot assistant who is very friendly and have emotions. The human says, how are you feeling today? How would the robot reply? Then ChatGPT can answer. It says, appreciate your asking, dear human. Today I'm feeling quite content and ready to assist you, etc. So you can get these kind of responses if you want, depending on how you prompt it. So can we use large language models for social robots? So there are clear differences here, of course, between ChatGPT and a social robot. ChatGPT uses only text. A social robot uses speech and also non-verbal signals in the face and the voice and so on. ChatGPT only involves one user, whereas in social robot, you might want to have multipart interaction. You have very clear turn taking in ChatGPT. You write something, you hit the return button, and the turn passes over. In a social robot, you might have real-time interaction. You want the robot to respond much faster, etc. Maybe give back channels. ChatGPT is more of a command-based interaction. I ask it to do things, it does it. I can ask it to revise, but it's not so much a back and forth conversation. In a social robot, you might want to have more of that depending on the application. ChatGPT, there is a lot of recent work in adding things like plugins and tools in order to connect it to databases. We might want to have that for robot, but maybe we also want to connect it into like sensors and actuators and so on, depending on what kind of application we have again. So short term, some of these issues can be solved with a regular language model if you use some kind of clever prompting. Long term, I think we will see fine-tuned models specific for social robots that can do these things more sort of out of the box without doing this kind of clever prompting. So as an example of how we can do this kind of clever prompting, I will show you an example of how we can use ChatGPT to generate facial expressions. So let's say we have the scenario of a robot that is used as a tool for training sales persons to handle problematic customers. We can ask ChatGPT like this. We ask it, the following is a conversation between a customer and a salesperson. The salesperson says, hi there, how can I help you? And we say, the customer says, these shoes broke after just 2 weeks. I want my money back. And then we ask ChatGPT basically to insert facial expressions from a list of expressions into these different places. And I will show you an example, and you can see that it actually works pretty well.
I am absolutely furious. These shoes broke in just 2 months. I want my money back.
What happened to them?
They just fell apart. The soles came off and the stitching ripped. I can't believe I spent so much money on these shoes for them to fall apart so quickly.
Okay, I think we can help you. You will get your money back.
Finally, some good news. Thank you. I hope I can trust that this will be taken care of promptly.
So as you can see, I managed to put a smile on her face in the end. Another thing we could potentially do is also incorporate non-verbal signals from the user. So here is an authentic example I tried with GPT-3. If the robot says it will rain the whole weekend and the human says, well, isn't that great? The robot will say, yes, it's great for the plants and the environment. Now, let's say we had some kind of sarcasm detector based on the voice or maybe the face of the user. We can feed that into the language model. So the robot says it will rain the whole weekend, and we put this sarcastic tag in there. Well, isn't that great? The robot will understand the sarcasm and say, I understand that you're not pleased with the forecast. Is there anything else I can help you with? Another example where we can do prompting is multipart interaction. So let's say we have a conversation between two users, user 1 and user 2, and a robot selling burgers. We can then ask the robot to include in parentheses who the robot is addressing. So it could be to both. How can I help you? The user 1 says, I want burger with fries. Now the robot addresses user 1. What would you like your burger to be topped with? Just a regular. Okay, we check that. Yes. Now the user 2, maybe we detect now that user 2 says me too. And the robot will address both and say, all right, 2 burgers with fries. Let's use tomato and onion, anything else. So here, not just does the robot understand who it should address, but also that who is saying what and how these two things are sort of related to each other. So that's actually quite nice. Another challenge is the real-time interaction. So GPT is inherently slow. It has to generate one token at a time in a sort of autoregressive manner, which means that the time to generate the sentence is linearly correlated to the number of tokens generated. And that can create very sort of slow responses. And in ChatGPT, you can see how they handle that by actually outputting word by word the response, but that doesn't really work very well in spoken interaction. Another problem of turn taking is quite complex. I've written a review article if you're interested to dive more deeply into it. But just to illustrate the point here, the user might say, I want to buy a sandwich, and the robot has to generate a response before it can start speaking and say, what topping would you like? The problem is that the user might get confused and say, hello, what's happening here? And you want to avoid that. So one sort of the way to handle that is that first you need some kind of turn end predictor that as quickly as possible can detect the turn end, and then you need to add some kind of response prefix generator. You can do this in a very simple way. Also with Furhat, you can do gaze aversion. I don't know, maybe you saw that in the case with the angry customer. We did that. You could add a phrase like, let's see, while the response is being generated by GPT. Another challenge is factualness. So you can see the disclaimer here that ChatGPT has. ChatGPT may produce inaccurate information about people, places, or facts. I think most people have experienced this, how it sort of hallucinates things. And this problem is especially sort of related to this kind of long tail knowledge. So if you ask it about common knowledge, like facts about World War II, central facts, it would mostly generate correct things. But if you ask it about long tail things like some information about some company or a person that is not very well known, it will likely make things up. And this has been shown also that this is a problem that is specifically related to this kind of long tail knowledge. This is an interesting paper exploring that. You can, to some extent, get around this problem by using a retrieval-based setup where, for example, if I ask about a company policy, of course, ChatGPT or the GPT model will not know anything about this specific policy for this specific company, but we can send that in a document retrieval step and retrieve the relevant document that describes this policy, and then large language models will be able to generate a more factual response. Another challenge is bias in models. This is very easy to illustrate. If you use GPT, for example, you can ask at every word or token it's producing, you can look for the probability distribution. So when we say here, when the doctor came into the room and ask it to predict the next word, we can see that it puts a quite high probability on the word he, 58%, but only around 5% on the word she. So clearly there's a bias here, and the model has learned the bias that we have about doctors being male. So this is, of course, a problem that to some extent you can try to fix with some kind of alignment, fine-tuning, and so on, but it's really hard to do. So it's very important to be aware of this problem. So to sum up, applying large language models to social robots, we have seen a lot of opportunities that I've tried to cover, especially when it comes to building interactions that are more non-scripted. Maybe training scenarios like virtual patients or handling customers that we saw, companion robots for education or for interviewing scenarios, for example, where it's very hard to define these interaction in more traditional approaches. And as we have seen, large language models can already today, to some extent, with clever prompting, account for multimodal input and output, and also multipart interaction to some extent. We have seen some challenges that still remain. How do you handle real-time interaction? How do we handle alignment and bias and factualness in these models? And probably we will see a lot of work on developing or fine-tuning large language models specifically for social robot that can handle these things. If you want to experiment using large language models together with Furhat, we have a tutorial on that. on how you integrate OpenAI, and then you can play around with this yourself. So with that, I would like to finish and thank you for listening. Goodbye.